looks like we're live. So, hello world, hello stream. We're here. So yeah, a couple hours to spend, and we'll just go over these. Oh, I'm so tired. Go over these questions. Yeah, we'll do that. And just kidding. So yeah, we'll go over these problems for a few hours. I think till around 9 o'clock or so, my time. Yeah. Yeah, let's just get into it. Let's just go. Let's do it. Let's continue. So this is kind of an interesting question. So I did a bunch of problems again at my work in between doing things, and they're challenging, I have to say. Definitely challenging. I will review the ones I've already solved, explain the answers, just go through them quickly. So, all right. This question is: write a function which returns a map containing the number of occurrences of each distinct item in a sequence. So this is effectively frequency map or histogram, however you phrase it. Think about it. The way we do this, we use a simple reduction, and what we want to do is reduce. We take off another function, and we take in a starting point, which is the map, right? Empty map. We have our collection, which will be the parameter, the anonymous parameter in our anonymous function. And the first parameter, the only parameter. And what we're going to do is we're going to associate with, so we have some value v, we have something we're going to return, the return hash map. And what we want to do is associate with, so associate takes a few arguments. Specifically, return is the map, it's going to be the map that we associate with. We want the key, which is going to be v, and the value that we're going to update with is going to be increment of, we can do or v, ret of v, or rather, there's a few ways to do this. Is that what we do, or ret of v, if it's not in there already? Yeah, that's a simple way to do it. Or would be ret of v and or 1. All right, so this construct returns either what's in the map given that key, or a 0, and then we increment it. Right, move one more over. Increment what we end up with here, and then we're going to associate in the map with this key this particular value, and then that gives us our function, and then we just reduce, we just execute this function, return the resulting map after each execution. We do that for every value in this collection. Let's see how this does. Yeah, there we go. That gives you a frequency map. Not bad. This is also a solution that someone else has already written. This wasn't what I came up with initially. What I came up with initially was way uglier, but that's a pretty good way to do that. So next, we're going to go to 56 for the occurrences. Find distinct items. Okay. Now this is oh, you already saw the answer. Yeah, I'll just review it, rewrite what it does. So this problem is basically unique, it's called, or Actually, I didn't even think of this, but you could just dump this thing into a sorted set and return the sorted set. Does that work? Excuse me, just set. I didn't even realize that. Set of, you can do this. Didn't even think of that. And you can return into from this set. What does that look like? Oh, okay, it doesn't work. Really? Why doesn't this work? I have the correct solution, but it just struck me that you could also do it this way, potentially. Let's get rid of all this. Excuse me. What do you get if you do this? Ah, that's why. It's going to be the other way around. You could reverse this even. Not into, but the other way around. You can do. If you do that. The way sequences and vectors are handled is different when it comes to insertions. Oh, okay. So it doesn't quite work the way we'd expect. That's fine. Anyway, it's not really a big deal. We don't. I was just curious about that. So the way you do this is, or one way to do this is, so you can do a reduction where you maintain two different data structures. One of them is a set, hash set of the values you've already seen, and the other is the result set. And you can reduce while sort of quote unquote building up those two sets as you go. And that's basically what we're going to do here. And then what you do is you build up those sets, then return the. Oh, but there was something in between we did here, some operation in between. Oh, no, that's it. No, that's it. Yeah, you just build up these two sets using a reduction. A special reduce function in between, perform a reduction, and then get the first of the result. And that's exactly what we'll do here. If you watch this carefully, you'll see what this does. So there's a threading macro we'll use, and we'll first define the function, the special function we're going to use, which has two, so you can use a destructuring to return, and the set and the value as we move through the collection. And this would be, so this is what we end up returning. It's going to be destructured as we walk through it. And actually, I want to put this all in one line because I want it to be nice and terse. Breviloquent, right? Breviloquent. So what we return is an if, and this if is going to have two pieces. Actually, well, three components of the if, right? There's the two different return paths, and the branch. So the branch is going to be V is in S. If V is in S, then you don't do anything. You don't change the set, nor do you change what you're going to return, right? Otherwise, you're going to append to the set. Now, the ret, I think we'll do vectors for the ret. That's fine. It doesn't really matter. You just do ret. Otherwise, ret, you add, is it v to ret? And the other one is add v to s. And what you do with this is, that's the function you're going to want to use. And what you do now is reduce. Now this is kind of interesting how this works. Notice we're going to make this an anonymous function, and we are going to include this parameter here. But the thing that's interesting is this threading macro is actually going to thread this function in first, and it's going to thread as the second parameter, which is kind of not the use case I typically have used for this, but now we have an empty set that we're going to be finagling with, and this is an empty, this will be the return vector, and this is the empty set of things we've already seen that's going to build up over as we go. And finally, we're going to take the first of what's left over here. And the way this works is it takes this function, threads it through here to reduce on our collection, and then you'll end up with this resultant vector that has what we want in the first slot and what we don't care for in the second slot. We just drop it. In that second slot, that'll be a set of numbers, and then we just take the first one, and that's it. And that ought to do it. Extremely concise. Breviloquence. That's what that is. All right, let's review that. Now let's go to 57. 57. Simple recursion. And obviously we've already. Oh yeah, this one is. Well, it's kind of. There's a comment to make about this one. It's just kind of neat. It's It is. Let me just check the analytics. Yeah, we're fine. Okay. I probably want to keep this up. What's interesting about this question is if you look at this carefully, this does a function foo when, and it'll recurse on foo, and it'll actually conjoin with the result of foo with x, whatever x is, and then this, I guess, doesn't return. It returns nil when x is not greater than 0, right? So when x is 0, this will just return nil. Otherwise, it returns a conjunction with a recursive call. What's interesting is if you conjoin with a nil, you actually end up with a vector and with that particular value, or you end up with a sequence with that particular value conjoined in the beginning of that sequence. So conjoining with nil creates a sequence with that element in it, which is why this function, this recursive function, works. Just kind of neat. This will actually give you the sequence 5, 4, 3, 2, 1. The sort of stopping point for the recursion is when foo operates on 0. Operates on 0. This actually returns nil because x is not greater than 0, so this whole function returns nil. So it becomes conjoined nil of x, where x is 1 after all of that. And it's kind of neat. You end up with a sequence with just 1 in it. And then the rest of this function, obviously, you just append the other values. All right, let's go to the next thing here. 58. 58. Okay, this I technically solved, and you can see how I solved it. It's kind of a mess. I was actually tinkering with this before I left and to come home. And this is interesting. So what this is, okay, so this will actually do together because I still need to get the right answer. There's a much more succinct way to do this, I think, and I just didn't do it correctly. I mean, I did it this way, but this isn't really the best way, I think, in my opinion. And I'll explain what both of these do. I'll explain what both of these do when I'm ready to to do so. So let's begin with reading the function. Write a function which allows you to create function compositions. The parameter list should take a variable number of functions and create a function that applies them from right to left. So you're going to be, so yeah, it's a higher order function, which higher order functions in simple terms take functions and return functions. So in this case, you take a sequence, a whole bunch of functions, a sequence of functions, and then it creates the composition of those functions as a function, and then returns that. So the way I did it recursively. I said, okay, if the number of functions in your argument list, number of functions you're giving to this composition, if it's just one function, then return that function, apply all these arguments. What you're going to do is return a function that takes a variadic number of arguments and then treats those arguments not as a sequence but as a series of arguments, which means you're going to use apply, and you're going to apply that to the function that was provided, right? So the composition of that function is effectively the same function, but the difference is, well, it becomes variadic. That's the first thing, which could cause issues, which I don't know if that matters or not. I don't think it does. I think it's okay. But you also end up with, so it's more or less the same function, but you also end up with, and not really. It's the same function, but whatever the errors that you would get for trying to provide it with too many arguments, you'd still have the same errors, I think, after compilation. So it doesn't really matter. It matters, but doesn't matter. I think it's fine. But the interesting part, so that's if you have only one function in the composition. If you have more than one function, so you have at least two functions, then you create a recursive composition. So then you apply, now this took me forever to figure out, but you apply from that sequence of functions, the first function to a recursive call of compositions with the rest of the functions with one less function. Which, but the tricky part was that you had to handle the apply like function, because you had variadic arguments going on in there, so it became rather confusing rather quickly. What we want to do, though, is even more interesting than all of that. We actually want to use a reduction on this, on the arguments themselves want a reduction on the arguments themselves, or function that represents a reduction on the arguments themselves by applying each function that you were given. So kind of a loop of functions, if you will, a little more, I guess, interesting than the recursive. It's more of like almost like an iterative version of the same thing. So we'll show you what that looks like, or I'll show you what that looks like. It's pretty neat, or I'll try to show it. So this one, if we take, let's do this, print line of this function apply the function to, so first apply it to, there's actually two pieces here. Applying that function, first you've got to apply it to another set of functions. So we'll do rest and reverse, right? So there's this function applied to these values, right, the sequence, and then give, 1, 2, 3, 4. Now calculate, right, apply that returned function to this argument, with this parameters, and then print the result. Yeah, which looks, it's gonna look kind of involved, but let's see if it should work. Let's see what happens. There we go. Okay, so 3, 2, 1. So what happens is create this composition, with rest in reverse, which is going to say, I think it does reverse first. Yeah, it does the reverse first, and then it does rest after. And so you end up with this 1, 2, 3, 4. And so now you're going to do this composition reverse then rest. So you do that, you perform it, and you end up with 4, 3, 2, 1, and then the rest is going to lop the 4 off, so you end up with 3, 2, 1. And then that gets returned and printed. What we want to do is do the same thing, but with a different function. Change this body. And there's something interesting here also you may have noticed is there's this pre. This is a precondition in Clojure. Clojure, you can do some pretty fancy stuff with conform, it's called, with the spec, Clojure spec. You could do a lot of validation on your inputs and the things that your functions work with, the data. It's like basically data validation. It's pretty powerful. It's pretty important, pretty good. Makes a big difference, I think, because it sort of confines your program to operate in a very I guess a controlled environment, something like that. It sort of basically does validation checks, which is, it's kind of a big deal when you're dealing with like complicated software, we'll say. You're dealing with like really high grade complicated software that's got to fit a lot of pieces in with other pieces. Yeah, having lots and lots of like checks and validation and ways of sort of controlling how people can interact with the code matters a lot. Yeah, makes a big difference. If you don't allow people to sort of get the program into a state that's not really, not just not meaningful, but like critically broken in the first place, this is kind of a big deal. Anyway, so yeah, that's just like a sort of validation, I think, and what it does just makes sure that everything that you're supplying is in fact a function. Obviously, this won't make much sense if you're trying to perform this with things that are not functions. In fact, it will most likely crash your program. So that's one of those validation checks that keeps your program from just crashing. So anyway, we want to, so we have this composition, we have these functions, this validation check, and what we're going to do is kind of fancy. We're going to return a function, right? Ultimately, we want a function. It's variadic, takes arguments, and what this function is going to do is reduce over with a special function that we'll get into shortly. Over your over the set of functions, and we're even going to reverse the functions. So we do this sort of properly, right? So we're going to go in the other direction, and what we're going to do is we're going to say, okay, give me. We're going to start with the arguments, right, as a sequence, and this is, so what this is a sequence of arguments, right, that are supplied to this function. So when you return the function, that the composition is going to take a sequence of arguments, a variadic number of arguments. But that is going to be arguments, but packaged in a sequence. So it's very important to remember that, and I'll get back to that later. But it's a sequence that we've got here, and then we're going to iterate over these this is the starting point. That's the function. And what am I missing here? Oh, excuse me. Yeah. This should look like this. Right. Yeah. So we're going to reduce with a function with the starting point where these are the arguments supplied, and we're going to perform this reduction in reverse on the reverse set of functions. So we're going to go however you got the functions as an argument list, we're going to reverse it, and we're going to start with the last one. So it's we reverse then rest. It'll start with the last one. So what we want to do now is, which kind of makes sense, right? It's sort of like from left to right, you would apply the rightmost to the leftmost. What we want to do now is say, okay, we've got some results of performing the first operation on these arguments, and then we've got another function, right? And you may have guessed what we're going to do is apply this function g on the results, right? So now this is the part it gets kind of tricky. This is really like very nuanced, subtle kind of thing, tricky thing. The first result that was the initial sequence of arguments, which is a sequence. Excuse me. So you actually need to apply g over these this sequence because the arguments are packaged in that sequence, right? Which then means you're going to call g with this first function with these arguments as they were presented to you. Okay, that's all well and good. Which, by the way, and what's really confusing about this is that if these are given as a single argument, which is a sequence, that means that this is a sequence with one argument, and that argument is a sequence itself. So you have a sequence with a sequence inside of it, which is a single argument. So this apply sort of reverses that outer sequence, and now we just have a single argument, which is a sequence, which then we then provide to g. So that's what this apply g res would do if you did it sort of like this. But now the thing that's tricky about this, what does this return, right? What this returns is the application of g over the sequence, over the single sequence that was provided as the single argument that was provided as a sequence, right? And so that there's some result of g. Now, in our case, that ends up being probably another sequence, right? Which is the single return value. But here's the tricky part. Here's the part that's awkward. If we just leave this as it is, and we say, okay, we're going to apply again, we're going to reduce, so we're going to apply again with the next function. What we're giving the next function is actually a sequence, which is it's that one value that has all of the returned stuff in that single value. Which, if you apply this, you're actually going to unpack all that sequence as a whole series of arguments, and then try to apply the next function on that series of arguments, which is actually not what you want to do, because this next function, as you can see, rest and reverse, these both take one argument, and that argument is a sequence. What we'd end up doing is actually, instead of giving rest one argument and that argument is a sequence, you give rest that sequence broken into a series of pieces, which is not what we want. So to avoid that, so that this apply works properly, we actually package up the result into another sequence in just the same way that when we use a variadic function, we specify a variadic function, it packages up all of the arguments into a sequence. So that is a very subtle thing, but that's what we're doing here. That's why you don't see this packaged up in a sequence, and then why you see the return packaged up in a sequence. Which is very, very subtle thing, very nuanced thing, and very easy to get incorrect. And actually, this thing I think works nicely. Let's see how it goes. I think that's it. I think that's all you need. It's like very simple as it turns out, but there's a subtlety here that's very hard to sort of piece together if you don't do it right. And then I think there's one more. Oh, there was something else. Yeah. So now you want to unpackage one more time, and what you do is you take the 0th element. Oh, okay. So the person that wrote this initially, that I took this from, I saw this. I was wondering what this 0 is doing here, and as you can see, this is the result is still packaged in this sequence, this vector. And so actually you use a 0 to get what's in there. And there you go, you end up with, oh no, didn't work. Wait a minute. Wait, what? Oh, that's because I didn't save this. And there you go, you end up with exactly what you're after. This should give you 3, 2, 1. Yeah, there you go. Isn't that amazing? That's pretty cool. And so you can, I don't think it's a good idea to compress this even more. I think both of these are probably about as legible as you should probably keep it about this legible. If you were to like put this all on one line or something, it would be like really hard to understand. It's kind of difficult to understand. It's pretty difficult to understand this on one line or on a few lines, but if you make it even more compact, it's even harder to understand. But yeah, that's what's happening here. It's pretty cool. That's pretty cool. Like I was impressed by this one. So there's two different approaches. One is a sort of using a single reduction, and the other one is using and applying functions in reverse. And the other one is to actually perform like recursion. And when you have one function, just apply that function, create that function, and then if otherwise, you would have a recursively compose the next function with the rest of the functions, recursively generated composed. So yeah, that's what you end up with. And let's go ahead and do the next thing. So great. What do we want here? Cool. So yeah, I thought that was pretty good. So we'll throw that in there as well. Let me see if I can. What do I want to do here? I forgot what I was even doing. I want to take this and throw it in here and just test that out. Yeah, there you go. Just so you have proof, quote unquote proof, that it does work. Right, these are obviously just a bunch of different functions with where you can compose them. So yeah, it's kind of neat. That's kind of neat. That's 58. Let's go to 59 now. I think that's where I left off. I think I was kind of stuck. Not stuck, but it was taking me a lot of time to really process and understand this last one here. Why it was done this way. Why it's sort of necessary. These pieces. I'd explain that. Now I'm not sure if that's. I think that's the correct way to do it. Yeah, I think so, because you gotta package up these variadic arguments. So you end up with this kind of funky thing you got going on. But I think it's right. I think it's the right way to do it. So, okay, juxtaposition next. So this is fresh. This is a new problem to me. So you guys can watch me struggle here. I know what this question is, though. I don't think this is gonna be that hard. I think this will be relatively easy. I think. We'll find out though. Take a set of functions and return a new function that takes a variable number of arguments, returns a sequence containing the result of applying each function left to right to the argument list. So this is a little different. What you're going to do here is, actually this isn't bad at all. I think this is fine. We're not going to try to do it inside the, and we're not going to try to do that inside of the inside of this editor. It's just kind of crazy. So we're juxt to, we're going to say, and the way this is going to work is we got a series of functions, and what we're going to do is return. Takes it, yeah, it's a new function. Okay, yeah, so it's almost the same thing as we did before, but a little bit different. So I'll show you what is different about this. We're going to use a reduction as well in this one. We could probably use recursion, but it's not entirely necessary. So what we want here is a reduction such that you apply each of these functions to a here's the tricky thing. What you want to do is you have the result, you have G, and you've got args, and this is entirely different now. What you're going to do at each step is actually conjoin with not args, but just an empty list here. And I guess you've got to have some functions. You have at least one function. F and the other functions. Could maybe I kind of want to like hold on, just yeah, I don't know. The reason I kind of want to enforce that you have at least one function. Just an and functions, and this probably looks weird, but the idea is that I want to have at least one function for this juxtaposition. I think it should have at least two functions, really. It doesn't really matter. It's just you need at least one function, I think, because without a function, it just doesn't make any sense. The composition, I guess. What happens if you have no function in the composition? Takes no arguments, because it's variadic and it could take no arguments. But hold on, let me see something here. Oops. Oh, let's delete everything else. If you did this with empty like, I wonder what happens if you do this. What even happens? Also, just comment that out while we're testing here, messing around. Tinkering, as they say. Tinkering. Really, so this will actually, if you do rest, this should work properly. There you go. So we do need something like this. Same thing. At least one function. At least one function. Let's try that now. Interesting. Does that work? No. What happened? What? Oh. You're kidding. Really? If this doesn't have anything in it, doesn't compile? This is at least two functions, I think. Wow. Can't take value of a macro. Oh, that's interesting. Really? Syntax error. You're kidding. Huh. Clojure and. Something tells me. I see what we can do. Okay. So we can't apply and in the way that I would like to. Okay. So actually that has nothing to do with how many functions we need here, I think. Well, maybe it does, I don't know. I think we got an error before, right? If we were just, yeah, okay. So we can give a single function here. And now if we do this, it should give us an error of arity rather than just like a runtime error, compiler error. Oh, good. Oh, I mean, okay. Try that again. Try that again. Oh, I'm so itchy. I don't know what's going on, man. Got so much itch. Maybe oh, okay. What is going on here? Whoa. Not mean to open that. Gotta be careful with Notepad++. It retains what you're working on, so there could be stuff in there you don't want to see. I don't want to show on stream. Okay. So Lenigan run compiling, wrong number of args. Yeah, there you go. So you get an arity exception. Okay, that's a little bit better. I think it's better than the other exception, which would be like probably like a runtime exception if you didn't do it this way. I like this. It's good. So yeah, okay. So we'll do rest reverse. We'll leave that where it is. We can get rid of this now, I think. Because this juxtapose, I want to do the same thing. Just make sure there's at least a function that we're using here. Excuse me. So you don't do and, you do every, and you're going to do function, and you're going to do cons f functions. Right? There we go. All right. So, very similar function, I think, to the one we just did. What we're going to do is use a reduction. We're going to use conj into this array that we return, which is going to be what we're going to conjoin is. Now, here's the thing I'm kind of uncertain about. We've got to actually apply these functions. Call it g. Apply g to the arguments. And these arguments, right, these are packaged. So, and, right, to this, yeah, okay. And this result we put in res, right? Can join it with res. Is that all we got here? And we don't need this though. Don't need that. I think that's it. I think that's it. What happens if we do this? What happens if we do this? I don't know. I don't know what's gonna happen. We'll find out. We'll find out shortly. Oh, look at that. Oh, that's exactly what we want. Wow, amazing. Amazing. So yeah, we get reverse, we get rest. Amazing. 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 Wow, did that very quickly. Just wasn't expecting to do that so quickly. Heck yeah, I'm the best. Oh yeah. Let's see solutions. Actually, that's kind of as good as it gets as far as I'm concerned. So we don't really need to look at the solutions, but we'll look at them anyway. It's pretty cool. It's pretty cool. That's pretty much what I did. Super simple. Map apply. Vector. I like this extra stuff in here. Make sure it's all functions and all that. Have a little bit extra error checking here. Do the recursive version. I think it's recursive. Actually, not sure what we did here. Amazing. Doesn't actually, I don't know if that's recursive. I don't know what he did. Huh. Yeah, this is actually might be one of the better. Might be better to do it this way. Use some anonymous functions to do this. Returns a function, given arguments, you map, apply F. Oh, that's kind of cool. I didn't think of that. Yeah, map would have been better than reduction. I didn't think of that. I did not even think of that. Oops. Oh. Yeah, you don't need to. Oh, I see. Oh, that's interesting. You could replace this with simple map and use an anonymous function to even simplify things even further. And you would take just apply the function to these arguments over, and this would be over cons f of functions. Oh, could do it that way too. You can do it that way too. That works too. That works too. That's what you're seeing in these solutions. These ones, more or less that. It's pretty good. That's pretty good. Write a function which behaves like reduce but returns each intermediate value of the reduction. Your function must accept either 2 or 3 arguments, and the return sequence must be lazy. Write a function which behaves like reduce but returns each intermediate value of the reduction. Your function, oh, this is reductions. Oh boy. Accept either 2 or 3 arguments, and the return sequence must be lazy. I can use reduce, but oh yeah, okay. So we're basically implementing each of the core functions of the Clojure language, which is great because in theory it's all pretty easy to do, right? So should have no problem. Should have no problem implementing these different things. Write a function which behaves like reduce but returns each intermediate value of the reduction. How do I do this? Excuse me. Well, you can perform like a meta reduce kind of thing. ironically, you can create the reductions using reduce. What it does is yeah, sure, yeah, okay. You need the same function signature as the reductions. I'll show you what that looks like. I just mucked up my glasses even more than they already made it worse. You know, I've been avoiding using the tissues because it looks like it looks like there's only one tissue in the box, which is not true, but it just looks like that, and I just don't think too much about it and don't try to get the tissues out of the tissue box, which sounds so strange, but yeah, that's what I was doing. So I just don't use them, which is really odd. All right, anyway, so what we want to do is yawn a bit, yawn publicly and on live stream, and while we're supposed to be working. What we want to do, what am I doing with this? Oh yeah, I want to see what's the Clojure Clojure docs, something in particular I'm looking for. Reduce what the signature looks like. What does the signature look like? F value collection, F collection. Okay, never mind. It doesn't have. Oh, if it doesn't have an initial value, then it calls F to get that value, which is kind of cool. All right, so we want, and we'll do this in here. Absolutely gonna do it. Let's do this guy. We're gonna go ahead and do this inside of our debugger, the debugger, the debugger, the debugger, the debugger, booger, yeah, the debugger. So, this. Reductions range. Tick 5. Whoa. Oh, I see. Oh, it could take a lazy sequence. Whoa. The return sequence must be lazy. Oh. Uh-oh. Is reduce lazy? Uh-oh. That's kind of a tricky property to get. I don't think reduce is lazy. Uh-oh. How come reduce treats my map like a list of vectors? Interesting. Okay, so reduce I think gives you lazy. Alright, I can't seem to find anywhere where it says if it's lazy or not. Anyway, okay. Right. Okay. 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 I believe reduce will give you a. I really hope it is. I believe it'll give you a. I believe reduce will give you a lazy sequence. Okay. Yeah, that's what we're looking for here. Okay. So let's continue. So what I want to do is apply to plus and range and print. Basically use this with our function. Print that. So inside here we're going to have our function, and we can just do this, I think. Right. Try to keep things somewhat organized. And we'll print this. Okay. Now inside here is where things are going to be interesting. So we get our function, and we've got, it's going to take the same signature, so it's going to be F and collection and value collection. We're just going to take collection for the time being. Yeah. No, it should be, there should be a value in there as well. So actually we need to use a function with the variadic, not variadic, the multiple arities. Multiple arity function Clojure. So we'll get some practice with that too. So this is param body. Okay. That's it. Really simple. You just define two bodies. It's interesting. So we've got so this will have F collection and F val collection. What we can do is generate what we want to do is say if there's no value, then you just call, we'll call this reductions2 with f, and then the value is going to be f called with no arguments, and then the collection, right? So this is how we handle the variadic case. And then, or yeah, the multiple arities. And then what we do here is say, we want to do, it's going to be a reduction, a special function. And we're going to have val as the initial state and this collection. Now the thing that's special is we actually want two things, I think. We can do it this way. Do two things. So we want this initial state. You know what we're going to do also? I was going to say we could also thread this, but I don't think we really need to thread it. What we're going to do is collect during the reduction. So this is going to operate a little bit differently. Val is the initial value. We'll say well, there's going to be ret like this. Yeah, this is cool. Okay. This is not too bad at all. Actually, this is kind of straightforward to do this. So we perform the normal reduction, which consists of just calling and returning f, right? So f on, and actually we want to use a destructuring here. It's not as normal as usual. So we have ret, we ultimately return, and I guess current, or R, we'll call it for reduce. And so we're going to return two values, which consist of for efficiency's sake, we could also for the sake of efficiency, we can do put a let in here. I don't know if it's that much more efficient. I think it's a little more efficient, but we'll do a let. So this is inside of a let, and the let we're going to do is we're going to say result or calculation, or I don't know. We could just call it z for lack of better expression. So apply f to r. That gives you z. Now what we're going to return is, hold on just a moment. Wow, my phone is just not charging properly anymore. I don't know what the deal is. Around 9 p.m. we're gonna go to bed. I'm really tired, so normally I wouldn't be that excited to go to bed, but and like stop what I'm doing, but I've just been going like all out all day, and I'm ready for bed. I'm ready for bed, man. So yeah, you're gonna let z be f applied to r, and then you're gonna return. You're gonna have z, right, is one value, but then you're also going to have the conjunction of ret and z. So you're gonna have this intermediate step conjoined with ret, and that is what you're gonna want to use. And then after you perform this reduction, get the first, which is the iterations in between, rather than right, you don't care about z anymore. And yeah, that's it. It's just a simple reduction on this arity, and obviously you just call reductions to once with f, where f generates something, and we'll see how this works, if this works at all. See what happens. It's an infinite loop. Uh-oh. Uh-oh. So I think what we want then is iterate rather than reduce. So we can do that too. That's fine. That's not a big deal. Iterate of this. The problem with this though is no, that doesn't make sense. I guess it does. I guess it's fine. The problem with this is, I think first is the problem, right? Like if we got rid of first, hold on, maybe first is the issue. Let's not get rid of reduce just yet. I don't think it's the reduce that's the issue. I think it's the first. That's the problem. I don't know what this does. We'll find out. If it takes more than a few seconds, then it's trying to go infinite. Okay, looks like it's infinite. Nice. Alright, we don't want that then. That is not what we want. That is not what we want. What we can do, so we can modify this a bit. Let's say, okay, let's see what this does. Alright, compiler error. Wrong number of arguments passed. I guess that makes sense. Oh, I did this wrong anyway. Oh, jeez. That was really loud. I did this wrong anyway. Alright. Excuse me. I did this completely wrong anyway. I'm supposed to have these this V from the collection initial value, and you're supposed to take this value V I did this so wrong. This return is supposed to be F applied to R V. Yeah. Right. And you apply this F to RV, and that's Z, and then this is, yeah, this is your, okay. All right, yeah, you know. What did I do? I think it's gonna work properly. It's supposed to be a lazy sequence. What if I just did this? just so I know I got the right idea here. Let's let f be plus, and let collection be the first. Just range of five numbers, 0, 1, 2, 3, 4. Okay. Okay. It's got these 5 numbers. Got this function plugged in plus in the range, well not range, but range of 5 to kind of keep it simple. Let's comment this out also, just so we excuse me. Core val cannot be number, right? Of course. What's this R? Oh, val is just plus. I think that gives you a 0. I hope. I don't know. Oh, it does. Okay, yeah, this is what we wanted. All right, so I'm not crazy. I just don't think this is a lazy sequence is the issue. Like if you do this with a range here, right? Place this the range. Try to reduce over a range. I don't think that is going to give you. I don't think that'll give you what you think you're going to get. I'll try to print that. Yeah, it does not give you a lazy sequence. Definitely not. No, certainly not. Right. Right. Okay. Now, I think I can do some recursion here. That's not what I'm after. How do I get lazy sequences? How do you make lazy sequences? You kind of want to do make compositions. Excuse me. Yeah, lazy sequence can be infinite. Iterate seems pretty good. Problem with iterate though is you need to take a value. Is there iterate over collection? Is that a thing? Oops. No. Yeah, it's not going to work because of no, that's not going to work. How do you operate on a lazy sequence? So we want to use a lazy sequence. We just make it lazy sequence. Does that work? How about that? Does that make it lazy? I don't think we can. Come on, man. Body of expressions. Only evoke the body first time. I think the issue is that if you reduce over this collection, you're just in trouble. I think that's the problem. I think it doesn't matter if you try to reduce over something infinite. It's like, it ain't gonna happen. It ain't gonna happen. Not a lazy language. Yeah. But you have some lazy sequences. Oh, what? What? Cons, fib sequence B, A plus B, lazy sequence. You gotta be kidding me. Return lazy sequences, produce lazy sequences, repeat iterate cycle. Wondering, so we want to produce a lazy sequence. So this can produce lazy sequences too. I don't know, man. How do we do this? I don't know. Dealing with infinite sequences. I want to say this is beyond me, but this is definitely not something I know offhand. I probably have to look this one. This is kind of tricky. This is sort of a language specific thing, because how do you get lazy sequences in the first place? I don't think reduce is going to give me what I want. I'll just say that right now. I don't think cycle is what I want either. repeat, excuse me, or iterate doesn't seem right either. I wonder if you map, right? If you map, oh, maybe you could do that actually. If you get this, wondering if you take this function and you iterate the function over, but the, I mean, you do have a starting value, but the problem is that there's also this as well. It's not really, I wonder if you can, oh, here's an idea. I wonder if you juxtapose this iteration with this collection. I wonder if you could do that. I wonder if that'll give you a lazy sequence. That'd be kind of cool. Maybe that's what you want. Hold on. Freaking brain blast over here if this works. Check me out. All right. So we want juxtapose, right? Juxtapose. I don't want reduce anymore. I want this function. And then we want range. So we apply to this juxtaposition to this range, and that's what we take 5 from, or we do it like this, right? And then we take 5 of those, and this is going to be iterate of this function. No, that doesn't make sense, does it? I don't think it does. No, it doesn't work. No, it doesn't make sense at all. I was thinking you apply this range to this, but that's not. That doesn't make sense, does it? Definitely not. No, I don't think so. It's just confusing. Yeah, that doesn't, no, never mind. All right, I don't know, it's too much. trying to make this work here. It's not. I think I gotta just sit and think about it for a while. Shucks, man. I don't know. I kind of wonder if you can use cons to create a sequence. Like, what if you just create a lazy sequence, a recursive lazy sequence? Can you do that? I mean, I guess you could. Say it ain't so. Say it ain't so. I think that's the only way to do it. I think that's it. I think we gotta just build this thing, man. What might this even look like? Can we? Oh, probably should have done that. Can we? What do we do? What do we do? Cons, right? Want to do something with cons. Let's try this. Let's do this. All right, I have an idea. Let's have a function, right? And we want this function to be like some sequence. And it's gonna, I guess it'll just return 0 to infinity, right? So just keep adding values. So we'll say not take anything. And we'll have this lazy sequence, right? And what it's going to do is cons with something. Cons of, I guess we could do, let's just do 0 for now, right? And that's going to be some sequence, right? Okay. So what you're telling me is if I print take 5 of some sequence, this will give me 5 zeros? No. Main, oh. Probably because this wasn't defined yet. Bet you if I look at the error, yeah. Okay, let's try again. See what we get. See how we do. Okay, I'm able to, alright. Make it a little simpler. Define it everywhere, or just define it, the function. Yeah. Create sequence from lazy sequence cons UUID sequence. Define UUID. String. Oh, you call some sequence to create. Okay. What? But somehow this works? They just lying to me? Does this not even work? Does this just not even work? And it's just claimed it did? Is that what's happening here? It's just like not even a thing. That would be kind of funny. Fib sequence 01. There's no arity. Right. Okay. AB, you get lazy sequence of cons. Alright, how about Fibonacci sequence? Apparently this one doesn't work. Which doesn't make a lot of sense to me, but fair enough. What do I know after all? What do I know after all? No. This literally doesn't work. This does not compile. you've got to be kidding me. What do you mean this returns? Oh, I see. Oh, that's what you got to do. Okay. Oh, I see. Okay. So that'll return the lazy sequence, and then you can operate on it. I understand now. Gotcha. So I was using this incorrectly. Alright. So they didn't lie. Okay. Not sure why I thought they did, but, you know. Wait, but that totally doesn't work. Oh, it's probably because this is not. Yeah, I see. I think I understand now. Possibly, maybe, hopefully. It works. Hey, okay. All right, I think I get it. So I can use cons to create this infinite sequence here. Okay. Yeah. Right. Of course. Right. All right. So we can create our own sequence, lazy sequence. All right. That's cool. That's good. I like that. It's a positive thing. Overall, positive thing. I guess we have to do this somewhat recursively. Excuse me. Well, I guess what this comes down to is kind of really want to go to bed. No. You can use this format. Don't think I really want to though. That's fine. So let's comment out this while we operate our code here, and let's say, all right, this is all well and good so far. We're not going to use first or reduce anymore. No, sir. We are going to define our own function completely, which is going to be a lazy sequence. And it's going to be cons of two things, which is reductions 2 with just reductions 2, I think. No arguments, no arity. What does this do? Lazy sequence, subsequence. I guess we do need one that has no arity then. What does it even return? I don't know. Can we just copy this and go all the way back and take a look? Yeah, I guess. Just fib sequence is 0, 1. The arity. Huh. Yeah, alright, never mind. I know what to do. So we don't even need this. Well, heck, man, I don't know. Right. Do we just make recursive calls? I feel like we just keep making recursive calls here. F val F new val ret. I don't know. I really don't know. know. Shucks. I have not the slightest clue what we're doing here. This is just confusing. I don't know. I don't know, man. Shucks. You want to operate on f val. There's some x, right? Where x is the next thing from this collection. Can we get next of collection? I think we can. Can we do this? Oh, that is so loud. Why is it so loud? So why is that the video that's coming up here? All right, next Clojure. All right, we're going to bed soon, so we should be fine. We should be okay. When writing lazy sequences, you should rest, not next. Okay. Yeah, we want rest. We want rest. Okay. Good to know. Thank you. Okay. All right, that's fine. This is fine. Everything's fine. So we're going to call this collection to get the rest. And we'll just call reductions 2. And we want first of this guy. Now, I don't know if it works like that. Maybe we just want like this. I don't know, man. All right. Call it ret, or it's really val. Right. Do we? I don't know, man. This is like, this is crazy. This is crazy. So we have a let, and we're gonna say let ret be this f, and we're gonna cons ret and recurse. I guess like this. I really don't know. It creates a lazy sequence. So if we reductions 2 on, this stuff, let's call it define reductions 2. There's no way this is right. There's no freaking way. So take 5 of reductions 2 of stuff. Function is going to be plus ret. Initial value we'll leave out, and we'll just say range. All right, how do we do here? Dude, I have no idea what this is going to turn out. No idea what this is going to look like here. Nice. Class cannot be cast to class function. unnamed module loader app. Lazy sequence. Oh, yeah, we don't need that, I think. It works. Heck yeah. Amazing. Wow. No kidding. I did it. Hey, I did it. Wow. Ain't that something? Amazing. Amazing. I don't think I do this any other way, by the way. I think this is it. I don't see a better way. Oh, that's really cool. That's really cool. I like that. I like that. Oh, okay, immediately fails. Nice. That's what I like to see. Wow. Wow. Okay. Still pretty good though. Reductions 2, let's use conj. And let's use, what is that? One and 2, 3, 4. So kind of expecting an infinite sequence here, I guess. If it's not infinite, then I don't know. I don't know what we're doing. Oh. Nil, nil, nil. Pretty close. Pretty gosh darn close. So, right. Yeah. Yeah. This is good. This is great. It's fantastic. What? What's going on here? If I get rid of this, what happened? Yeah, it just doesn't work. Okay, that's fine. Well, mostly because this already just doesn't exist. But if we didn't do that. No, you get the same thing. Okay, interesting. Does really make a difference. Oh, no, wait, get rid of both. Just see what happens. Find out. Find out. Alright, it's time for bed. We'll come back to this tomorrow. I want to run away from this problem. I want to run. So it looks like it doesn't matter. It looks like just the logic itself is kind of flawed here. So this only matters if you don't give it a value, but this part matters quite a bit. If you call f of val, right, then you've got this ret. You have cons ret with reductions of f, the same f, ret again, and the rest of the collection. Now the problem is what we expect is actually 1, 1, 2. So, oh, because we shouldn't call this first. That might be the problem. Ah, that's interesting. Didn't even think of that. Start with val. Aha. Maybe that's what I'm doing wrong. Yeah, maybe I don't need that. So you start with val, and then you f a val of the first collection, first value in the collection, and recurse. Haha. Zero, 0, 1, 3, 6. Okay. Right. Plus collection. Shucks. You add 0 to the. Oh. So actually. Uh-huh. Looks like looks like it shouldn't be F. It looks like it should actually just be or maybe this is right. I'm not really certain even. Does that work? Is that correct? No. I'm very confused. Just trying to get this top one correct first. Why am I not getting that one correct is a question. I feel as though if we just call F, excuse me, the problem with that is that we still need to operate on the rest of this here. And then we cons with val top of F, which doesn't make a lot of sense. But the thing is, if we try to do the rest of the collection here, oh, no, I think maybe that's okay. Let's try that, just see what happens there. But then don't we skip a value if we do that? It feels like we're skipping a value if we do it this way. Because, yeah, we called F, but shouldn't it be, should you not just call this directly? Even though you don't have a value? Shouldn't this be better? Shouldn't this be what you do? That still work? I don't know. Okay, still works. Alright, that looks right for the top one. The bottom one, though, we have one extra thing going on here. And why? initial value. Why is there nil at the end? What is going on? F of 4. Can join 1, 2, 3, 4 with first of the collection, rest of the collection. Maybe we just need the collections and not nil. This kind of automatically handles that though, right? 1, 2, 3, 4, 5. Oh. Right. No, this is fine. All these nil values is just because I take so many. Maybe I had it right the first time around. No, I didn't. 1, 2, 3, 4. No, 1, 2, 3, 4, 5. No, definitely not. This is interesting. I think this is what we want, actually, this function. One, two, three, four. It's not really take 5, it's actually just, I think if we don't take 5, oh, okay, yeah, that's fine. No, of course. Okay. Yeah, certainly. Let me just say if empty collection if it's empty, then we simply return this. And this is going to be a sequence. I think you can do just cons of this. Creates the sequence with just that value. So if it's empty, I don't know. Actually, if it's empty, I think we even just do cons. Do that. cons of nil, right? Oh my goodness, please. I think that's it, just an empty sequence. Oh, there we go. Okay, cool. All right, and finally, very excited, man. Very excited. So this last of this thing, we want to say we want to reduce 2 times, right, so that should give us 120. Yeah. Or not even the last, but what does this give us? Alright, let's try that again. Pretty cool, I think we got it. Although that took a while. Nope, did not get it. Maybe got it. Let's find out. We shall see. We shall see. 2, 6, 12, 24, 120. 6, 24, yeah, there you go. Cool. Awesome. Very cool. Alright, let's take this. So that's somehow, there we go. Alright, we'll come back to this later. Not that now. But somehow this recursive function gives us a reductions, implementation of reductions. Use lazy sequence and cons in conjunction, and that'll give us, it'll be lazy, which is pretty cool. So we can take a certain number. That's pretty cool, man. That's pretty cool. And then obviously we can force this to be truncated at some point as well by giving it a base case and the collection's empty, right? Because we're operating on the rest of the collection. Awesome, man. That's cool. I like that. That's great. I thought this reductions program was like super fancy, I guess. Well, I guess it is kind of fancy. It's in this lazy sequence with cons that somehow operates correctly. Very cool. So now we know how to create lazy sequences in Clojure. Let's go ahead and end stream here. So thank you all for watching. We'll check out the solutions to this one later. Next stream, probably tomorrow, we'll stream. We're making headway. We've got less than 100 problems left on the site. So we're moving right along. I think the more we do them, the better we'll get. So it'll be faster as we go. Although there are quite a few hard problems we haven't seen yet. So I don't think we've seen any really hard ones. So that'll be interesting. But yeah, thanks again, and talk to you soon. Take care.